Start recording. Good morning, students. Students, as you know, we're doing unit 3, that is playing with numbers. Our topic is playing with numbers, and in previous lectures we discussed a few questions of exercise 3.1. Clear, students? Now question number 1 to 15 of exercise 3.1 is already complete. Now only one question is pending, that is question number 16. So in this lecture first we'll discuss question number 16, then we'll start our next topic. Okay? Yes, students. Now question number 16, exercise 3.1. Last question, exercise question number 16. Yes, students. Your 16th question is express each of the following number as the sum of three odd primes. Express each number as the sum of three odd primes. Odd primes. Yes, students. Your first condition is number should be odd and prime, odd prime number. The number which we will add, it should it may the numbers which we are adding are odd as well as prime. Clear, students? So first number is 21. Yes, students, express number 21 as a sum of three odd prime numbers. Three odd prime numbers. Yes, students, to express 21 as a three odd prime numbers, first we'll make a list of all prime numbers as we've done in previous lecture. So first we will prepare a list of all odd prime numbers, then we try. So now number is 21, and you can see the list on page number 46. List is already there, and now try odd prime numbers. Add three odd prime numbers as we get result 21. So our first number is 3 plus 7 plus 11. 3, 7, 11. First of all, 3, 7, 11. All these three numbers are prime numbers, and 3, 7, and 11 are also odd numbers. So these are odd prime numbers. Now add them. 7 plus 3 is 10, 10 plus 11 is 21. So our three numbers are 3, 7, and 11. Clear, students? Next is yes, students. So next number is 35. Now, students, express 35. Express 35 as a sum of three odd prime numbers. So our first number is 5, plus 11 plus 19. Now you can see 5, 11 and 19. 5, 11, 19. All these three numbers are odd numbers, and 3, 11 and 19 also prime numbers. Now add them. 11 plus 5 is 16. 11 plus 5, 16. 16 plus 9 is 35. So three numbers are 5, 11 and 19. 5, 11 and 19. Clear, students? Our next number is third number is 49. Now express 49 as three odd prime numbers. These three numbers are 7, 11 and 31. 7, 11 and 31. 7, 11, 13 odd numbers. 7, 11 and 31 also prime number. Now add 11 plus 7. 11 plus 7 is 18. 18 plus 31 is 49. Clear, students? Now last number is 63. Last number is 63. Now add 7 plus 13 plus 43. 7, 13, 43. 7, 13, 43 odd numbers, and 7, 13 and 43 is also prime number. Now add 7 plus 13 is 20. 7 plus 13 is 20. 20 plus 43, 63. So number are 7, 13 and 43. Every number are 7, 11 and 31. Clear, students? So this is the last question of exercise 3.1. Clear, students? Now we discuss next topic, that is divisibility test. Our next topic is divisibility test. Divisibility test. Yes, students. First, what are divisibility test, and what is the difference between division and divisibility test? Yes, students. When we divide two numbers, then we perform division. Then when we divide any two natural numbers, then we will divide these numbers, and we will perform division and find what is quotient and what is remainder. Is our number is fully divisible or not? But in divisibility test, without performing actual division, we know is this number divisible by exactly divisible by given number or not. Without performing actual division, we know are these two numbers are exactly divisible or not. For example, we have a number 260. Now by divisibility test, we know without doing performing division, we know is this number is 260 exactly divisible by 2 or not. Clear, students? So these are divisibility tests. There are few rules which we follow in divisibility test. So I will discuss uh, these rules one by one. Your first rule is divisibility by 2. Your first rule is divisibility by 2. By 2. Yes, friends, divisibility by 2. When we know is given number is fully divisible by 2 or not. For this, friends, our rule is if last digit if last digit of any natural number is 0, 2, 4, 6 or 8. If last digit of any number is 0, 2, 4, 6 and 8, then our number is divisible by 2. So first we'll write the rule. If last digit is 0, 2, 4, 6 and 8. If our last digit of number is 0, 2, 4, 6 and 8, then our number is divisible by 2. For example, we have number 7486. Without forming actual division, now tell me what is this number is fully divisible by 2 or not? You just know, observe last digit. Our last digit is 6. It means this number is fully divisible by 2. When we divide 7486 by 2, then our remainder is 0. So it means our last digit is 0. It means 7486 is fully divisible by 2. Now consider one more number that is 5663. Now, is this number 5463 divisible by 2? Now observe last digit, that is 3. Now last digit is 3. It means 5463 is not fully divisible by 2. So since like this, we know is these numbers divisible by 2 or not. Without performing actual division, we know this number is exactly divisible by 2 and this number is not divisible by 2. Clear, students? Next is divisibility by 3. Divisibility by 3. Second rule is by 3. First divisibility by 2, next is divisible by 3. Yes, friends, a number is divisible by 3. A number is divisible by 3 if sum of all digits, if sum of all digits is divisible by 3. So first we'll write the rule. If sum of all digits is divisible by by 3. Now I will explain this rule with the help of example. So let us consider one number that is 124. Now without performing actual division, we want to know, is this number exactly divisible by 3 or not? So add these three digits: 1 plus 2 plus 4. 4, the answer is 4, 5, 6 is 7. Now divide 7 by 3. Divide 7 by 3. 3 2 are 6 and remainder is 1. If sum of all digits is divisible by 3, it means 124 is not divisible by 3. Now, so one more number, 126. Now add these all numbers: 1 plus 2 plus 6. 6 plus 2, 8 plus 1, 9. 9 divided by 3, 3, 3 are 9. So it means 126 is fully divisible by 3. And 124 is not fully divisible by 3. So our rule is, if a number is divisible by 3, if sum of all digits is divisible by 3. So student, these are two rules: divisibility by 2 and divisibility by 3. Clear, students? Next is divisibility by 4. Divisibility by 4. By 4. Yes, students. Divisibility by 4. Yes, students. A number is divisible by 4 if last two digits are fully divisible by 4. First we'll write the rule, then I will explain with the help of example. A number is divisible by 4 if last two digits divisible by 4. Yes, friends. For this, let us take a number 7036. Your rule is, a number is divisible by 4 if last two digits are divisible by 4. Now, for example, we'll take a number 736. Now, last digit are 36. Last two digits 36. Now 36 divided by 4. 9 4 are 36. So remainder is 0. So it means 736 is divisible by 4. Next number, second number, we have 7385 082. Is this number divisible by 4 or not? So just the last two digits, 82. Last two digits are 82. Now in rough side, 82 divided by 4, 4 2 are 8, and remainder is 2. So this number is not divisible by 4, and 736 is exactly divisible by 4. 736 is divisible by 4, but this number is not divisible by 4. Okay, so this is third rule. Divisibility by 4. Next is 4. Divisibility by 5. Divisibility by 5. Yes, friends. Divisibility by 5 is number is divisible by 5 if last digit is 0 or 5. A number is divisible by 5 if if last digit of number is 0 or 5. Then we can say this number is exactly divisible by 5. So first we'll write the rule. If last digit is 0 or 5, a number is divisible. Our rule is a number is divisible by 5 if our last digit is 0 or 5. Yes, for this example, for example, let consider number 23,486, and our second number is 23,460 and 18,155. Yes, students. Now, just observe last digit. In first number, our last digit is 6. It means this number is not fully divisible by 6. Now, in second number, our last digit is 0. So, it means this number is divisible by 5. And in third number, our last digit is 5. So again, this number is divisible by 5. From these three examples, first is not divisible by 5, and second and third, these two numbers are divisible by 5 because our last digit is 0 and 5. In second number we have 0, and in third number we have 5. So it means these two numbers are divisible by 5. Clear, students? Next is divisibility by 8. Fifth rule, divisibility by 8. By 8. Yes, friends. Without performing actual division, how we can say this number is exactly divisible by 8 or not? Yes, friends. Our rule is a number is divisible by 8 if last three digits. A number is divisible by 8 if last three digits are divisible by 8. First, we'll write the rule. If last three digits divisible by 8. A number is divisible by 8 if last three digits are divisible by 8. So now let's consider two examples. Now our first number is 78,056, and our second number is 3,94,148. Yes, friends. Now, just note last three digit 1, 2, 3. Last three digits are 0, 5, 6, 6. So will we consider at 56. Now divide 56 by 8, 0, 5, 6. We consider 56. Now 56 divided by 8, 56. So remainder is 0. So last three digits are divisible by 8. It means this number is divisible by 8. Now in second example, our last three digits are 146. Now in rough side, 146 divided by 8, 66. 8 are 64 and remainder is 4. The students, when we'll divide last three digits 146 by 8, then our remainder is 4. So it means this number is not divisible by 8. So students, divisibility rule for 8 is a number is divisible by 8 if last three digits are fully divisible by 8. Clear, students? Next is divisibility by 9. Sixth rule, divisibility by 9. By 9. Yes, friends, divisibility by 9. Now is a number is divisible by 9 if sum of all digits is divisible by 9. Same as divisibility or test of 3. The rule of divisibility of 3 and divisibility of 9 are same. If sum of all digits is divisible by 9, then we can say this number is divisible by 9. If sum of all digits is divisible by 9, then we can say number is divisible by 9. For this, students, let us consider two examples. First is 7,186. Now add all these digits. 7 plus 1 plus 8 plus 6. 7 plus 1, 8. 8 plus 8, 16. And 16 plus 6 is 22. 7 plus 1, 8. 8 plus 8, 16. 16 plus 2, 22. Now 22 divided by 9. 9 2 are 18. Remainder is 4. So it means this number is not divisible by 9. Now another example, 7,686. Now add all these numbers. 7 plus 6 plus 8 plus 6. 7 plus 6 is 13. 7 plus 6 is 13. 13 plus 8, 21. 21 plus 6 is 27. 27. Now 27 divided by 9. 9 3 are 27. Remainder is 0. So it means this number is divisible by 9. So rule of divisibility by 9 is, if a number is divisible by 9, if sum of all digits is divisible by 9. Now students, last rule, divisibility of 10. Divisibility by 10. By 10. Yes students. The rule is, a number is divisible by 10. A number is divisible by 10 if last digit is 0. If last digit is 0. Yes friends, a number is divisible by 10 if last digit of number is 0. For example, we have two numbers, 5746 and 8940. Now the note last digit. In first number, last digit is 6. It means it is not fully divisible by 10. 5746 is not exactly divisible by 10. And in second example, our last digit is 0. So it means this number is divisible by 10. First number 5746 is not exactly divisible by 10, and 8940 is divisible by 10. So rule is, if last digit is 0, then we can say number is divisible by 10. So students, today your homework is complete exercise 3.1 and revise these divisibility tests. Thank you. Have a nice day.